In this tutorial, we'll learn how to use the Frequency List plugin for the Butter text analysis software. What this plugin will do is count up the number of times that every n-gram occurs within our data set. An n-gram is essentially a way to describe the length of different phrases. So a 1 gram is also called a unigram, and those are just single words. 2 grams or bigrams are 2-word phrases. 3 grams are also called trigrams, and those are 3-word phrases, and so on. So this plugin will go through the text and count up the number of times that every single type of phrase occurs within our data set. So I'll go ahead and give you a quick example of what this looks like if you're new or just generally unfamiliar with this concept. So here I've got a data set full of different TED Talks. Each file has a different TED Talk transcript inside. And when we look at what these look like, if we're going through and counting unigrams or just single word phrases, you would start with the first word and count the number of times that the word so shows up. So here you can see it shows up at least a couple of times. As we scroll through, the word so appears every so often. So we would just count those up, and then we would have a sense of how many times this word occurs within our data set. Now bigrams would be 2-word phrases. So then we're looking at so I. So we would count every time so I appears within the data set, and you can see it's much less frequent. It may just show up that first time. If we're looking at trigrams, then we're looking at 3-word phrases, so we would count the number of times that so I think shows up in the data set. And we would go through the entire text and do this. We would count the number of times that so I think shows up, the number of times that I think data shows up, the number of times that think data can shows up, and so on. So what this plugin will do at its core is count the number of times each of these phrases occurs and give us that number. And it'll also tell us what percentage of the total texts contain those n-grams in the first place. So if we have a word that appears only in one file, but a very large number of times, so often you'll see this with things like names or specific places or titles, they may show up at a high frequency, but they only occur in maybe 1 or 2 different texts. So we'll get that information as well, the percent of documents in which the n-grams are observed. And then we'll also get some calculated collocation statistics, like log dice and NMPI. I won't go into much details about how these are calculated or what they mean. This is information you can find in a number of publications elsewhere online. Just know that it calculates some of these so that we can help kind of partial out which of these n-grams seem to be more meaningful than others. So let's go ahead and go through an example where we're going to count, let's say, trigrams and below for all of these different texts, all these different TED Talks. So let's go ahead and load these in from the text files. And if I'm moving a little bit fast, you don't need to worry. Each of these plugins I'll be using are going to have their own tutorial videos, so if you need to know more about each one of these, then you can look at their respective tutorials. So in short, what I'm doing here is I'm reading in the texts and then tokenizing them, because the Frequency List plugin requires tokens as input. So we need to take the texts, split them up into their parts, and then in my case I'm going to remove stop words. This isn't something that you necessarily always will want to do, and it'll depend a lot on the type of text analysis task that you're going to be doing later. If you're interested in counting punctuation marks or stop words as part of your n-gram collection, then you won't want to do this. In my case, typically what I'll remove is punctuation and some of the more common numbers. But mostly we're just focused on cleaning up the punctuation so that the data set is a little bit more readable. Now before I go into the settings here, I'm going to go ahead and attach a Save Output to CSV plugin. So the frequency list plugin is going to generate all of that information I described earlier, frequencies, percent of observations that include n-grams, some of these collocation statistics, and we want to make sure that we save that frequency list to a CSV file so that we can actually look at it later. And I'm going to just name this butter output frequency list. So let's go ahead and look at the frequency list settings so that we know what we're doing. So there are a lot of settings here, and I'm going to try to move through them fairly quickly. If anything here is a little bit too confusing, or if I move through it too quickly, you may also consider just playing around with different numbers. You notice that pretty much all of these are numeric values, and so what you can try doing is running a frequency list and then changing the numbers and seeing how it affects the results that you get. Now some of these are very important. So the very first setting, n-grams, n equals blank. So this is essentially the n in n-grams that we're setting. If we want to extract unigrams or single word phrases, we'll just leave this at 1. If we want to extract bigrams and trigrams or higher, then we'll need to turn this up. Now note that when we turn this up to a higher n value, it's going to also extract the lower value n's as well. So this will extract, as it's set right now, trigrams, but we'll also pull out and count up the bigrams and unigrams as well. Now the omit n-grams with frequency less than option, what this will do is it'll cut out n-grams that don't occur very often within our data set. So if we have words that are relatively rare, and most words are relatively rare, then we want to just remove those because there's not much good in tracking those values if it's just 1 or 2 times in our entire data set. For most linguistic and psychological or social scientific purposes, words that only appear once or very rarely are generally not super meaningful for the kind of common text analyses that people will do. Now if you have a really large data set, you may want to turn this up. If you have a really small data set, you may want to turn this value down. Just know that we're going to omit any n-grams with a frequency less than this across our entire data set. If you're getting a frequency list as output from this type of pipeline, and it doesn't have very many or no n-grams at all, you may have this value a little too high, which means that you're just omitting all of your n-grams because they're not frequent enough. Now similarly, this third setting here is omit n-grams occurring in less than X% of documents. So just because words are very frequent doesn't mean that they're appearing in a lot of different texts. A lot of times if you have kind of very messy data or data that has some peculiar properties to it, you may have some n-grams that occur at very high frequency, but they don't appear in very many documents. So this setting here will let you filter out n-grams that aren't commonly used, or they're not spread out across a decent number of documents. Now the prune interval is very important. So this is a bit more complicated than we'll go into in great depth in the video. Just know that extracting a frequency list can use a lot of your computer's resources. In particular, it can be very memory intensive or very RAM intensive, as we're holding a really big list of n-grams and trying to count them up over the entire data set. So one way that we can work around this problem is to trim off those really uncommon n-grams. Often these are misspellings or just incredibly rare or large words that nobody uses. And if they show up once in our data set, we don't necessarily want to keep holding on to that information because we simply don't have the memory to do so. So what this setting will do is it will prune our frequency list every once in a while. In particular, it will prune our frequency list after we've added or counted up every certain number of n-grams. So by default, this is set at 10 million. If you're working with a really difficult data set, you may want to turn this up higher or lower. For the most part, this should be fine on most modern computers, but if you find that it's printing too frequently or not frequently enough, this is the option that you would change. Skip text with less than X tokens. So if you have texts that are really short, you may want to just omit them entirely from your frequency list generation. This kind of works in tandem with this setting here that I talked about earlier. If you have texts that have just 1 or 2 words in them, you may or may not want to include the words that are in those texts. So if there are only 2 words in a text, what that can do is really drive down this score here, the percent of text that any given word appears in. Generally speaking, this is fine. If you're working with different types of data, you may want to adjust this value accordingly. So for example, if you're looking at texts that are all really long books or novels, generally speaking, those are pretty long. So you might want to turn this value up higher so that you're filtering out relatively small texts, relatively in terms of the size of your average text. Similarly, you would probably want to turn this value much lower if you're working with really short texts. So if you're working with Twitter data or tweets, most of those really are only 5 to 10 words long. So if you have this value set too high, you're just going to omit all of the tweets in your data set. Now these bottom 2 settings are a little bit complicated, and I won't get into it too much. Just know that, at least right now, as of the time of recording this tutorial, this plugin generates 2 different collocation scores, normalized pointwise mutual information and the log dice score. I won't go into how these scores are calculated or really too much in depth in terms of what they mean. Just know that these are different scores that can be used to help identify n-grams, 2 grams and higher generally, that are meaningful phrases. And so, depending on this value here, we'll filter out n-grams where the selected metric doesn't reach this value. So if we set this at NPMI, for example, any collocate with a NPMI score of less than 0.5 is going to be removed from our final frequency list. Now you can change this value pretty much as low or as high as you want. If you don't really want to filter out n-grams based on some kind of a collocation measure, that's okay. Just turn the value very low and negative. We'll go ahead and leave this back at its default, 0.5 for now, just so you can see how this works. And I'll say this again, as you're working through a frequency list, and you're seeing the results that are generated by this plugin, you might consider playing around with these settings to see how they impact the results that you get. So, we're going to go through this, and we'll look at the frequency list, and then we'll also kind of talk about how the results that we see correspond to each of these settings. So we'll go ahead and run this here, and this will take a minute to run. And in the meantime, I'm going to go ahead and bring this file over here so that we can look at it. Now, the way that this process works is we have to count up the n-grams as they occur throughout the entire data set. So we're not actually writing any data to this output file right now. What happens is the information gets aggregated. Every so often, the 10 million n-gram mark or so, the program, or I should say the plugin, automatically goes through and just cleans up the frequency list a bit and filters out those low frequency n-grams. Then, once we've worked through the entire data set, you'll see down here that it'll tell us that the plugin is finalizing. What this means is that we're then going through this entire batch of n-gram information that we have and calculating up all the results. We're adding up the number of times that every n-gram occurs. We're calculating what percentage of the documents contain each n-gram. And we're also calculating those collocation scores for things like log dice and normalized pointwise mutual information. Now we're almost done here, so we're about ready to see what this frequency list looks like. I'm going to go ahead and open these settings back up just so we can get a sense of how the results that we see correspond to the settings of this plugin. So let's go ahead and zoom in a little bit so that we can take a better look at our results. So the first thing that we note is that the segment column is being used to tell us the frequency rank of every n-gram. The most common n-gram is the word the, which is a unigram, which we can see by the phrase length. I'll go ahead and expand these a little bit more. The second most common word is the word and if you work a lot with looking at probabilities and frequencies of word, this is very normal. This is what you would expect to see. And this is also why a lot of people use stop words to remove these really, really common words that appear in pretty much every single text. So here we have these actual n-grams themselves. And you can see the most frequent ones are, for the most part, unigrams, although down here we start seeing bigrams with a little bit more frequency. So we have the n-grams themselves, we have the frequency of each n-gram, and this is after filtering out all the information. So given this setting here, the omit n-grams with frequency less than 25, the lowest frequency value that we should see here is 25. Yep, nothing in here has a frequency of less than 25, which is what we would expect to see. Now, of course, there are a zillion other n-grams that appeared in our data set, but most of them occurred at really, really low frequencies. You can see if you were to plot this column here, that it starts out very high and then has a long tail. Very quickly, these numbers get very small relative to this first number. And this is also some standard property, also known as a Zipf distribution, that you would expect to see in a frequency list. Now the documents column tells us how many documents in our data set this n-gram showed up in. The observation percent column is similar. This tells us what percent of our total documents did this n-gram show up in. IDF is the inverse document frequency column. I'm not going to go into what this measure means. There's a lot of information on the internet about the IDF score. Just know that you can use this with certain frequencies to calculate other information when you're going through and processing texts. Now the phrase length column just tells us what the n in the n-gram is for each of these. So we have single word phrases like around, we have two-word phrases like a lot, and kind of, and we should have some trigrams in here as well. So I'm going to go ahead and sort by this column. There we go. A lot of one of the I want to. So here we have our trigrams, and below we had our bigrams and unigrams. Now these two scores here, NPMI and log dice, these are both collocation statistics. And again, I'm not going to go too far into what these mean. Just know that this is something that we filtered out by. So we chose to filter out anything with an NPMI score of less than 0.5. So if we go to the bottom here, none of these scores should fall below that. And that's the case. And if you sort by these columns, you'll notice that the phrases are generally a bit more meaningful the higher that the collocation scores are. So for example, the United States, ladies and gentlemen, the US, in New York, and so on, these are a bit more meaningful than the lower scoring phrases, like interested in and said I want. So often you'll want to turn the score up a little bit if you're finding that your collocates at the lower end of the spectrum aren't particularly meaningful and informative. And the same is true for log dice as well. You notice there's some overlap between them and that high scores on this metric generally correspond to higher scores on this metric as well. The United States, ladies and gentlemen, these are still showing up at very high scores for both metrics, but you can filter out based on either of these. And that's it. That's how you use the frequency list plugin for Butter.